Hello everyone, and I know it's been a bloody long time since I uploaded anything, and I never shown you my complete lab. So I finally got my ATX power supply working, my oscilloscope running, and in its own kind of a housing on which I've kept my parts rack. And a quick update, this will make sense to a very few of my subscribers. Don't worry, it's coming. Okay, so here I've attempted MOSFET gate driving. I thought I'd try it for myself. Eventually I had to, and what my original plan was to use a very simple half bridge push-pull driver. No level shifting. I came to know about level shifting only today. So my previous experiments didn't work. I blew up my Arduino. I destroyed one 555 and one 2N2222 transistor. And in the end, I used this L293 motor driver to drive the gate of my MOSFET. Pathetic. I don't have any gate drivers. I've got to buy them. And about my 555, I finally decided to use a 50% duty cycle variable frequency configuration. This space is for the gate driver, and I've decided to use a separate gate driver, by the way, because I have to get this thing done quickly. As you can see, the flyback converter is yet to be put together. So about the L293 motor driver, the internal schematic looks something like this. There are 4 channels, just a mirror image of 2 channels, sorry, these two are coupled. A mirror image of this on the other side. So you have 2 buffers, protection steering diodes, an enable pin and an input pin. So on this input pin I have a square wave from the 555 timer, and this enable thing is supposed to go high, so I've connected it to 5 volts, and the input voltage is, as you can see, 12 volts. My current probe is my current meter isn't showing anything. I have no idea why. It's running though. So I've connected power. Oh god damn this focus. Anyways, I've connected power to 12 volts, and I've put all the 4 channels of this driver in parallel. So I think I'm getting around an amp or so of gate drive. This chip is getting, ouch, quite hot, excuse me. And now I'll show you the actual oscilloscope waveforms. No, this is more convenient for now. So the yellow trace on my oscilloscope is the signal from the 555 timer, 55% duty cycle, and the frequency is 53 kilohertz, almost exactly, though the max operating frequency of this motor driver is 50 kilohertz, so I decided to push things up a bit. So the yellow trace is the PWM signal from the 555 timer. The blue trace, this one, is the MOSFET gate waveform. So you can see 12 volts peak to peak from the motor driver, and the pink or purple trace is the drain to source voltage. All this is pretty decent. So let's zoom in a bit and look at our rising and falling times. Yeah, that should be enough. As you can see, there's a propagation delay between the rise of the PWM signal and the gate voltage, and there's this small slope here which I can't seem to explain. Must have something to do with the gate capacitance or something. It's at 200 nanoseconds per division, so 1, 2, 3, 4, 5, or 4 because half here and half here, so that's a bit less than a microsecond. 800 nanoseconds propagation delay, but the drain to source voltage fall time is quite decent. I can't seem to zoom in more than that, around 50 nanoseconds. And now let's have a look at the B falling edge. Quite similar. The drain to source voltage increases slowly, so I'm having some turn off trouble and some ringing here. This voltage decreases quite fast. So yes, I've made some very good progress. At least I got this fixed. Now I just need to get myself a MOSFET gate driver. I need to look up the part numbers. So that's basically what I've done so far. And I also made a few other interesting acquisitions, if you will, acquisitions on Amazon. The first of which is this, a 4-button LiPo charger. Even though I don't have a LiPo battery, very stupid, I know, but still I thought this might be useful. Of course it will be useful. It can charge NiCad, NIMH, lead acid and lithium polymer batteries, and that's where I got these nice thick cables from. This is what I've been using it for. These cables are really handy, so even if you don't need this, definitely get this charger for just for the cables. And I also got myself a new set of tips for my soldering iron, different types. It's currently on the fine chisel tip. So that's pretty much it for now. I'll get back to you ASAP.